Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of the electronic circuit and we are discussing the electronic component, and up to now we have discussed the many components which are used in the preparation of the electronic circuit or electronic gadget. The today's topic is the field effect transistor. So, up to now we have discussed what are the field effect transistor and what are the characteristics and what are the parameters required in the preparation of the FET and in the use of the FET. Now, we discuss the classification of the FET. On the basis of its construction, FET are classified as number 1 is the junction FET, that is the JFET, and second type of FET is the metal oxide semiconductor FET, that is MOSFET. First is the JFET. So, FET, field effect transistor, divided into classified into the two category. First is the junction FET and second is the metal oxide semiconductor FET. Again, if we talk about the JFET, it is further differentiate in the depletion mode, and metal oxide semiconductor FET in the depletion as well as in the enhancement mode we can use it. Then it is further in the P channel and the N channel on the basis of the majority carrier classified. Again, depletion mode is classified into P and N, and the enhancement mode classified into the N and the P channel. N and P channel, which is based upon the majority carriers used in this FET for the flow of the current. So, you see on the screen they are the basic symbolic representation of the N channel, where the arrow is going opposite to the gate, but in the P channel it is moving towards the gate, and you can see N channel and P channel for the metal oxide, and all are having the various different symbols. So, these are the symbol. You see G for the gate, D for the drain, and S for the source. So, these are the basic classification of the FET. The two primary type of the FET are the junction FET and the metal oxide semiconductor MOSFET. That is the MOSFET, JFET, and second is the MOSFET. What is JFET? ETS, they are the simplest type of the FET and usually used in the low noise amplification, and the gate is formed by a PN junction, hence the name is the F junction FET, where we just the gate having the junction, that is why the gate is formed by the PN junction, that is why its name is the junction FET. Next is MOSFET, that is most widely used type of the FET. You have listened many times in the laboratories that we are using the MOSFET, or in the electronic circuits in the electronics labs you see that we use the MOSFET, and the MOSFET is metal oxide semiconductor FET, especially it is used in the integrated circuits. The MOSFET features a metal gate separated from the semiconductor by a thin layer of insulating material, and that insulating material may be the silicon dioxide. Again, I repeat that the MOSFET features a metal gate separated from the semiconductor by a thin layer of insulating material, and that insulating material is the silicon dioxide. That is why the gate is made by the junction PN junction, here the metal gate we use, that is why it is a MOSFET. So, here the name is the metal oxide semiconductor FET. Now, we will discuss in detail as FET is of the two types, first is N channel type and the P channel type. The channels that form between the terminals are the foundation for how JFET junctions functions in the devices. Either the N type or the P type of channel may exist. It is known as the N channel JFET because the N type channel, and the P channel JFET because it formed the P type channel. You see on the screen that this is a symbolic representation of the P channel as well as the N channel. As you see in the P channel, the arrow is towards the gate, but here in the N channel the arrow is towards the drain and source and opposite to the gate. So, these are the symbolic representation of the JFET. You see the arrow is the at the last of the is just near to the source. So, this is the P type channel and N type of channel. What is the working of JFET? As a JFET construction is similar to that of the BJT in that it can be formed using the N type and the P type material. The N type sandwiched between the P type or the P type are sandwiched between the N type. So, they are like PNP or they are like the PNP or the NPN transistor as in the BJT, bipolar junction transistor, and are formed in the FET, and these JFETs have a channel that can be of the P type or the N type. What is the working of the JFET? It is classified as in the N type or the P type JFET depending upon the channels. Positive side of the N channel JFT is connected to the source terminal, and similarly here in the N channel JFT the drain terminal has the highest potential compared to the gate in case of the JFT, where the N channel JFT connected to the source terminal and the N channel JFT the drain terminal has the highest potential compared to the gate. So, the junction formed by the interaction of the drain and the gate terminals will be biased in the opposite direction in case of the JFT. As a result, the width of the depletion region near the drain is greater. The depletion layer, the width of the depletion layer near the drain is greater than that of the width of the depletion layer near the source. So, depletion layer in this case will be near to the drain and it is far from the width of the depletion layer is less in case of the source. So, because of this the majority of the charge carriers which are electrons can be seen flowing from the terminal drain to the source. So, as the potential at the drain tends to increase and the flow of carriers, so does the flow of current as electrons are flowing from the terminal drain to the source. So, the potential at the drain towards increase the flow of carriers and that will increase the flow of current towards the drain. Now, however, when the voltage at the drain and the source are increased, the current flow is stopped now. So, if the voltage increase, then the current will be stop now. JFT is well known for its ability to control the current through the application of the input voltage. So, by using the JFT, we can control the current when we control the input voltage. So, this is the JFET. In this type of transistor, the input impedance has reached a maximum value. So, there is no current evidence at the gate terminal when the JFET is in its ideal mode. That is how the N channel JFT operates. Only by varying the polarities of the supplies does the FET function as the P channel FET. Similarly, we can take the holes as the flow and control the current. So, similarly we can use the P channel JFT. The next type of transistor, FET transistor, is the MOSFET, and this operation of the MOSFET is based on the channel that exists or formed when the voltage is applied. So, MOSFET are classified into the two types, which is based upon their mode of operation. First, on the basis of the mode of operation, the two typed MOSFET are there. First is the depletion mode and second is the enhancement mode, and further it is classified into the N channel and the P channel. In the enhancement mode, the channel is induced by applying voltage to the gate, whereas in the depletion mode it operates due to the already existing channels. In the enhancement mode, the channel is induced by applying voltage to the gate. The channel is induced by applying a voltage to the gate, whereas in the depletion mode the MOSFET operates due to the already existing channel. So, the N channel MOSFETs are known as the NMOS, and that is represented by the symbol. It is shown below. You see here we are having a enhancement type NMOS and depletion type NMOS. So, you see the difference between that. Enhancement type NMOS having there is no connection between the source and drain, they are separated. Source, drain are separated, the channel is also separated, but here you see in the depletion mode all the drain, source are connected through a line. So, N channel MOSFET are known as the NMOS, and these are the symbol for the enhancement type and the depletion type that will be in the circuit diagram. So, PMOS, where the P channel MOSFET, and they are represented by the symbol as you see here. All the thing is that here the arrow is defined. So, enhancement mode type, and this is the depletion type PMOS for the P channel. A channel is formed in enhancement mode when the voltage applied to the gate terminal exceeds the threshold voltage, and it could be the N type for the P substrate and the P type for the N substrate. So, in the enhancement mode, we further classified into the P enhancement MOSFET, that is N MOSFET, and second is the P type enhancement mode, that is the P MOSFET, and based on the channel formation. So, MOSFET of the enhancement type are more commonly used than those of the depletion type. So, in the MOSFET with enhancement type are used. So, we can use it. Now, what are the advantages of FET? So, FET, as the input impedance of the FET is of the several mega ohms. So, we use it in the many electronic component where we require the several mega ohm output. So, radiation has less of effect on the FET than that it does on the BJT. So, sometimes we apply this in where the radiations are more at that level. So, we use this FET. Temperature stability are greater than that of the BJT in this case. When we compare with the BJT, there is a less noise, and can be manufactured with the less processing and of the smaller size, and that is used in the integrated circuit, and that is why they are most commonly used in the electronic gadgets. And longevity and the efficiency is more in the FETs as compared to the BJTs, and it is application with the low frequency requirement, where we use the low frequency requirement and then we use this type of FET. It is a unipolar device, so we use in the unipolar devices. FET used in the unipolar devices. Device for controlling the voltage, controlling the current, so we use this FET. They are more thermally stable as compared to the BJT. So they are having the voltage regulator, so we use in the voltage regulators also, so that we can control the voltage and current in the voltage regulator. Apart from this, we are having the many disadvantages of the FET, as the cost is more than the junction transistor. When we compare it with the BJT, this product has a lower gain bandwidth, and because of the transconductance is low, voltage gain is also low. So there are, when we require the high voltage gain, but there are advantages because of the transconductance is low in the FETs. So they are the some of the disadvantages of the FET. It has a faster switching time than the BJT. So sometimes the system is not work properly because it is having a faster switching time. During the installation, special care must be taken in the installation of the FET, field effect transistors, where when the performance of FET degrades as the frequency increases, and that produce the noises, and this is due to the feedback from the internal capacitors. Apart from these many disadvantages, FET are having a vast application which are mostly used in the electronic circuits. We can control it. The research is going on, and there are the many projects are going on to increase the efficiency of FET. Now, what are the application of FET? FET are widely used in the integrated circuit because they take up the less space than the BJT chips. So most of the integrated circuit use the FET. Then FET are used as a voltage variables resistors, that is also known as the WRs, in the operational amplifiers in the op-amp. And you see that in the op-amp we can use FET and MOSFETs, and that is also used in the tone control devices, FM, in the FM and the TV receiver mixtures and the logic circuits. We use the FETs. Despite their lower operating speed, FET are commonly used in the digital switching circuits. So other applications of FET are the low noise amplifier, so it is used in the noise removal. So buffer amplifier, we can use it as a cascade amplifier, and log switching, we use it in the chopper, we use in the multiplexer, we can use it in the current limiter, we can use in the phase shift oscillator. So there are lots of application of the FET, and it is a small device and that can be used in the integrated circuit. So field effect transistor are having the more application as compared to the BJT. So up to now we have discussed the what is FET and how we can control the current by using the FET, how we can classify the FET in the two types. We can classify like JFET and MOSFET FET. Apart from this, we have discussed its advantages, its parameter, and what are the applications of this FET we have discussed up to now. So FET are widely used in the integrated circuit because it is a less space and it is easy for the construction. Thank you very much.